CulturaX, a cleaned, enormous and multilingual dataset for large language models in 167 languages. The driving factors behind the development of large language models, LLMs, with impressive learning capabilities are their colossal model sizes and extensive training datasets. Along with the progress in natural language processing, LLMs have been frequently made accessible to the public to foster deeper investigation and applications. However, when it comes to training datasets for these LLMs, especially the recent state-of-the-art models, they are often not fully disclosed. Creating training data for high-performing LLMs involves extensive cleaning and deduplication to ensure the necessary level of quality. The lack of transparency for training data has thus hampered research on attributing and addressing hallucination and bias issues in LLMs, hindering replication efforts and further advancements in the community. These challenges become even more pronounced in multilingual learning scenarios, where the available multilingual text datasets are often inadequately collected and cleaned. Consequently, there is a lack of open source and readily usable dataset to effectively train LLMs in multiple languages. To overcome this issue, we present CulturaX, a substantial multilingual dataset with 6.3 trillion tokens in 167 languages tailored for LLM development. Our dataset undergoes meticulous cleaning and deduplication through a rigorous pipeline of multiple stages to accomplish the best quality for model training, including language identification, URL-based filtering, metric-based cleaning, document refinement, and data deduplication. CulturaX is fully released to the public in Hugging Face to facilitate research and advancements in multilingual LLMs, project's website. Contrastive decoding improves reasoning in large language models. We demonstrate that contrastive decoding, a simple, computationally light, and training-free text generation method proposed by Lee et al. 2022, achieves large out-of-the-box improvements over greedy decoding on a variety of reasoning tasks. Originally shown to improve the perceived quality of long-form text generation, contrastive decoding searches for strings that maximize a weighted difference in likelihood between strong and weak models. We show that contrastive decoding leads LLaMA 65B to outperform LLaMA 2 GPT 3.5 and Palm 2L on the HelloSwag Common Sense Reasoning benchmark, and to outperform LLaMA 2, GPT 3.5, and Palm 540B on the GSM 8K MathWord reasoning benchmark, in addition to improvements on a collection of other tasks. Analysis suggests that contrastive decoding improves over existing methods by preventing some abstract reasoning errors, as well as by avoiding simpler modes such as copying sections of the input during chain of thought. Overall, contrastive decoding outperforms nuclear sampling for long-form generation and greedy decoding for reasoning tasks, making it a powerful general-purpose method for generating text from language models. PDFTriage, question answering over long structured documents. Large language models, LLMs, have issues with document question answering, QA, in situations where the document is unable to fit in the small context length of an LLM. To overcome this issue, most existing works focus on retrieving the relevant context from the document, representing them as plain text. However, documents such as PDFs, web pages, and presentations are naturally structured with different pages, tables, sections, and so on. Representing such structured documents as plain text is incongruous with the user's mental model of these documents with rich structure. When a system has to query the document for context, this incongruity is brought to the fore, and seemingly trivial questions can trip up the QA system. To bridge this fundamental gap in handling structured documents, we propose an approach called PDFTriage that enables models to retrieve the context based on either structure or content. Our experiments demonstrate the effectiveness of the proposed PDFTriage augmented models across several classes of questions where existing retrieval-augmented LLMs fail. To facilitate further research on this fundamental problem, we release our benchmark dataset, consisting of 900+ human-generated questions over 80 structured documents from 10 different categories of question types for document QA. An empirical study of scaling Instruct-Tuned large multimodal models. Visual instruction tuning has recently shown encouraging progress with open-source large multimodal models, LLM, such as LLaMA and Mini-GPT-4. However, most existing studies of open-source LLM are performed using models with 13B parameters or smaller. In this paper, we present an empirical study of scaling LLaMA up to 33B and 65B/70B, and share our findings from our explorations in image resolution, data mixing, and parameter-efficient training methods such as LayoutNUWA. These are evaluated by their impact on the multimodal and language capabilities when completing real-world tasks in the wild. We find that scaling LLM consistently enhances model performance and improves language capabilities, and performance of LayoutNUWA tuning of LLM are comparable to the performance of full model fine-tuning. Additionally, the study highlights the importance of higher image resolutions and mixing multimodal language data to improve LLM performance, and visual instruction tuning can sometimes improve LLM's pure language capability. We hope that this study makes state-of-the-art LLM research at a larger scale more accessible, thus helping establish stronger baselines for future research. Code and checkpoints will be made public. Adapting large language models via reading comprehension. We explore how continued pre-training on domain-specific corpora influences large language models, revealing that training on the raw corpora endows the model with domain knowledge, but drastically hurts its prompting ability for question answering. Taken inspiration from human learning via reading comprehension, practice after reading improves the ability to answer questions based on the learned knowledge. We propose a simple method for transforming raw corpora into reading comprehension texts. Each raw text is enriched with a series of tasks related to its content. Our method, highly scalable and applicable to any pre-training corpora, consistently enhances performance across various tasks in 3 different domains: biomedicine, finance, and law. Notably, our 7B language model achieves competitive performance with domain-specific models of much larger scales, such as Bloomberg GPT-50B. Furthermore, we demonstrate that domain-specific reading comprehension texts can improve the model's performance, even on general benchmarks, showing the potential to develop a general model across even more domains. Our model, code, and data will be available at the project's website. LayoutNUWA, revealing the hidden layout expertise of large language models. Graphic layout generation, a growing research field, plays a significant role in user engagement and information perception. Existing methods primarily treat layout generation as a numerical optimization task, focusing on quantitative aspects while overlooking the semantic information of layout, such as the relationship between each layout element. In this paper, we propose LayoutNUWA, the first model that treats layout generation as a code generation task to enhance semantic information and harness the hidden layout expertise of large language models, LLMs. More concretely, we develop a code instruct-tuning, CIT approach, comprising 3 interconnected modules. 1. The Code Initialization (CI) module quantifies the numerical conditions and initializes them as HTML code with strategically placed masks. 2. The Code Completion (CCC) module employs the formatting knowledge of LLMs to fill in the masked portions within the HTML code. 3. The Code Rendering (CR) module transforms the completed code into the final layout output, ensuring a highly interpretable and transparent layout generation procedure that directly maps code to a visualized layout. We attain significant state-of-the-art performance, even over 50% improvements, on multiple datasets, showcasing the strong capabilities of LayoutNUWA. Our code is available at the project's website. MindAgent, Emergent Gaming Interaction. Large language models, LLMs, have the capacity of performing complex scheduling in a multi-agent system and can coordinate these agents into completing sophisticated tasks that require extensive collaboration. However, despite the introduction of numerous gaming frameworks, the community has insufficient benchmarks towards building general multi-agents collaboration infrastructure that encompass both LLM and human NPCs collaborations. In this work, we propose a novel infrastructure, MindAgent, to evaluate planning and coordination emergent capabilities for gaming interaction. In particular, our infrastructure leverages existing gaming framework to require understanding of the coordinator for a multi-agent system, collaborate with human players via unfine-tuned proper instructions, and establish an in-context learning on few-shot prompt with feedback. Furthermore, we introduce Cuisine World, a new gaming scenario and related benchmark that dispatch a multi-agent collaboration efficiency and supervise multiple agents playing the game simultaneously. We conduct comprehensive evaluations with new autometric COS for calculating the collaboration efficiency. Finally, our infrastructure can be deployed into real-world gaming scenarios in a customized VR version of Cuisine World and adapted in existing broader Minecraft gaming domain. We hope our findings on LLMs and the new infrastructure for general-purpose scheduling and coordination can help shed light on how such skills can be obtained by learning from large language corpora. Sorted LLaMA, unlocking the potential of intermediate layers of large language models for dynamic inference using sorted fine-tuning, SOFT. The rapid advancement of large language models, LLMs, has revolutionized natural language processing, NLP. While these models excel at understanding and generating human-like text, their widespread deployment can be prohibitively expensive. Sorted net is a recent training technique for enabling dynamic inference for deep neural networks. It leverages network modularity to create submodels with varying computational loads, sorting them based on computation accuracy characteristics in a nested manner. We extend SortedNet to generative NLP tasks, making large language models dynamic without any pre-training, and by only replacing standard supervised fine-tuning, SFT, with sorted fine-tuning, SOFT, at the same costs. Our approach boosts model efficiency, eliminating the need for multiple models for various scenarios during inference. We show that using this approach, we are able to unlock the potential of intermediate layers of transformers in generating the target output. Our submodels remain integral components of the original model, minimizing storage requirements and transition costs between different computational latency budgets. By applying this approach on LLaMA 213b for tuning on the Stanford Alpaca dataset and comparing it to normal tuning and early exit via pendulum benchmark, we show that sorted fine-tuning can deliver models twice as fast as the original model while maintaining or exceeding performance. Cure the headache of transformers via collinear constrained attention. As the rapid progression of practical applications based on large language models continues, the importance of extrapolating performance has grown exponentially in the research domain. In our study, we identified an anomalous behavior in transformer models that had been previously overlooked, leading to a chaos around closest tokens, which carried the most important information. We've coined this discovery the headache of transformers. To address this at its core, we introduced a novel self-attention structure named Collinear Constrained Attention, COCA. This structure can be seamlessly integrated with existing extrapolation, interpolation methods, and other optimization strategies designed for traditional transformer models. We have achieved excellent extrapolating performance, even for 16 times to 24 times of sequence lengths during inference without any fine-tuning on our model. We have also enhanced COCA's computational and spatial efficiency to ensure its practicality. We plan to open source COCA shortly. In the meantime, we've made our code available in the appendix for reappearing experiments. Struc-Bench. Are large language models really good at generating complex structured data? Despite the power of large language models, LLMs, like GPT-4, they still struggle with tasks that require generating complex structured outputs. In this study, we assess the capability of current LLMs in generating complex structured data and propose a structure-aware fine-tuning approach as a solution to improve this ability. To perform a comprehensive evaluation, we propose Struc-Bench, include 5 representative LLMs, that is GPT-NeoX20B, GPT-3.5, GPT-4, and Vicuna, and evaluate them on our carefully constructed datasets spanning raw text, HTML, and LaTeX tables. Based on our analysis of current model performance, we identify specific common formatting errors and areas of potential improvement. To address complex formatting requirements, we utilize Format COT, chain of thought, to generate format instructions from target outputs. Our experiments show that our structure-aware fine-tuning method, when applied to a LLaMA 7B, significantly improves adherence to natural language constraints, outperforming other evaluated LLMs. Based on these results, we present an ability map of model capabilities from 6 dimensions, that is, coverage, formatting, reasoning, comprehension, pragmatics, and hallucination. This map highlights the weaknesses of LLMs in handling complex structured outputs and suggests promising directions for future work. Our code and models can be found at project's website. TextBind, multi-turn interleaved multimodal instruction following. Large language models with instruction following abilities have revolutionized the field of artificial intelligence. These models show exceptional generalizability to tackle various real-world tasks through their natural language interfaces. However, their performance heavily relies on high-quality exemplar data, which is often difficult to obtain. This challenge is further exacerbated when it comes to multimodal instruction following. We introduce TextBind, an almost annotation-free framework for empowering larger language models with the multi-turn interleaved multimodal instruction following capabilities. Our approach requires only image caption pairs and generates multi-turn multimodal instruction response conversations from a language model. We release our dataset, model and demo to foster future research in the area of multimodal instruction following. Recovering from privacy-preserving masking with large language models, model adaptation is crucial to handle the discrepancy between proxy training data and actual users' data received. To effectively perform adaptation, textual data of users is typically stored on servers or their local devices, where downstream natural language processing (NLP) models can be directly trained using such in-domain data. However, this might raise privacy and security concerns due to the extra risks of exposing user information to adversaries. Replacing identifying information in textual data with a generic marker has been recently explored. In this work, we leverage large language models, LLMs, to suggest substitutes of masked tokens and have their effectiveness evaluated on downstream language modeling tasks. Specifically, we propose multiple pre-trained and fine-tuned LLM-based approaches and perform empirical studies on various datasets for the comparison of these methods. Experimental results show that models trained on the obfuscation corpora are able to achieve comparable performance with the ones trained on the original data without privacy-preserving token masking. A distributed data parallel PyTorch, implementation of the distributed Shampoo optimizer for training neural networks at scale. Shampoo is an online and stochastic optimization algorithm belonging to the Adagrad family of methods for training neural networks. It constructs a block diagonal preconditioner where each block consists of a coarse Kronecker product approximation to full matrix Adagrad for each parameter of the neural network. In this work, we provide a complete description of the algorithm, as well as the performance optimizations that our implementation leverages to train deep networks at scale in PyTorch. Our implementation enables fast multi-GPU distributed data parallel training by distributing the memory and computation associated with blocks of each parameter via PyTorch's D-tensor data structure and performing an all-gather primitive on the computed search directions at each iteration. This major performance enhancement enables us to achieve at most a 10% performance reduction in per-step wall clock time compared against standard diagonal scaling-based adaptive gradient methods. We validate our implementation by performing an ablation study on training ImageNet ResNet 50, demonstrating Shampoo's superiority over standard training recipes with minimal hyperparameter tuning. Stack and delay, a new codebook pattern for music generation. In language modeling-based music generation, a generated waveform is represented by a sequence of hierarchical token stacks that can be decoded either in an autoregressive manner or in parallel, depending on the codebook patterns. In particular, flattening the codebooks represents the highest quality decoding strategy while being notoriously slow. To this end, we propose a novel stack and delay style of decoding strategy to improve upon the flat pattern, decoding where generation speed is 4 times faster, as opposed to vanilla flat decoding. This brings the inference time close to that of the delay decoding strategy and allows for faster inference on GPU for small batch sizes. For the same inference efficiency budget as the delay pattern, we show that the proposed approach performs better in objective evaluations, almost closing the gap with the flat pattern in terms of quality. The results are corroborated by subjective evaluations, which show that samples generated by the new model are slightly more often preferred to samples generated by the competing model given the same text prompts. Augmenting text for spoken language understanding with large language models. Spoken semantic parsing, SSP, involves generating machine comprehensible passes from input speech, training robust models for existing application domains, represented in training data, or extending to new domains, requires corresponding triplets of speech transcript semantic parse data, which is expensive to obtain. In this paper, we address this challenge by examining methods that can use transcript semantic parse data, unpaired text, without corresponding speech. First, when unpaired text is drawn from existing textual corpora, joint audio text, JT, and text-to-speech, TTS, are compared as ways to generate speech representations for unpaired text. Experiments on the STOP dataset show that unpaired text from existing and new domains improves performance by 2% and 30% in absolute exact match, EM, respectively. Second, we consider the setting when unpaired text is not available in existing textual corpora. We propose to prompt large language models, LLMs, to generate unpaired text for existing and new domains. Experiments show that examples and words that co-occur with intents can be used to generate unpaired text with LLaMA 2.0. Using the generated text with JAT and TTS for spoken semantic parsing improves EM on STOP by 1.4% and 2.6% absolute for existing and new domains respectively. S3, DST, Structured Open Domain Dialogue Segmentation and State Tracking in the era of LLMs. The traditional dialogue state tracking, DST, problem aims to track user preferences and intents in user-agent conversations. While sufficient for task-oriented dialogue systems supporting narrow domain applications, the advent of large language model, LLM-based chat systems has introduced many real-world intricacies in open domain dialogues. These intricacies manifest in the form of increased complexity in contextual interactions, extended dialogue sessions encompassing a diverse array of topics, and more frequent contextual shifts. To handle these intricacies arising from evolving LLM-based chat systems, we propose joint dialogue segmentation and state tracking per segment in open domain dialogue systems. Assuming a zero-shot setting appropriate to a true open domain dialogue system, we propose S3DST, a structured prompting technique that harnesses pre-analytical recollection, a novel grounding mechanism we designed for improving long context tracking. To demonstrate the efficacy of our proposed approach in joint segmentation and state tracking, we evaluate S3DST on a proprietary anonymized open domain dialogue dataset, as well as publicly available DST and segmentation datasets. Across all datasets and settings, S3DST consistently outperforms the state-of-the-art, demonstrating its potency and robustness, the next generation of LLM-based chat systems. Enhance audio generation controllability through representation similarity regularization. This paper presents an innovative approach to enhance control over audio generation by emphasizing the alignment between audio and text representations during model training. In the context of language model-based audio generation, the model leverages input from both textual and audio token representations to predict subsequent audio tokens. However, the current configuration lacks explicit regularization to ensure the alignment between the chosen text representation and the language model's predictions. Our proposal involves the incorporation of audio and text representation regularization, particularly during the classifier-free guidance (CFG) phase, where the text condition is excluded from cross-attention during language model training. The aim of this proposed representation regularization is to minimize discrepancies in audio and text similarity compared to other samples within the same training batch. Experimental results on both music and audio generation tasks demonstrate that our proposed methods lead to improvements in objective metrics for both audio and music generation, as well as an enhancement in the human perception for audio generation.